Here's level 2 calculus question 1. Here we're given a function and we're asked to find the gradient. The word gradient should trigger that you need to differentiate. So first of all I'm going to write out the function in terms that we normally like the x to the power of 5 first, decreasing in the x powers. Differentiate, multiply by the power, reduce the power by 1. And we're given some information there that x equals -1. So each of those x's I'm going to replace with -1. That will give me an answer of 16 when you work it out on your calculator. That will give you your first achieved question. For the next one, we've got the gradient of a point on a curve is given. That dy over dx means it's being differentiated. It's like writing y dash. So here we have the gradient function. Write it out, and we're given that 1, 1 lies on the curve. So we have to find the equation of the curve. So we have to add 1 to the power, divide by the new power, add 1 to the power, divide by 1, add your constant. Tidy it up a bit. Now use that point 1, 1 for x and y, and you'll find that the value of c is -4, and then you write those write the equation that I've underlined in blue there with the c value of -4, and that will give you relational thinking merit. For this one here, you're given the acceleration. You're told that the car was travelling at 45 meters per second, perhaps like the one that just went past, as it passed over the finish line. So the acceleration is given there. We want the speed, the velocity. So we add 1 to the power, reduce the power by 1. So -10 becomes -10t. We add a constant. Now we're told that it's 45 meters per second when the time is 0, because as it passed over the finish line. So obviously the constant is going to be 45. So we can write out our velocity equation. Instead of having a c there, we write 45. Now, how far did it travel after passing the finishing line? Well, it would have travelled until it stopped. So we want the velocity, or its speed, to equal 0. That's when the car stopped. If you're not moving, you've obviously stopped. So put 0 into there. Solve it. After 4.5 seconds, the car has stopped. So we want a distance formula, because we're asked how far. So we add 1 to the power, divide by the new power, and add your constant. That's taking the velocity equation to find the distance. Anti-differentiate. So then we tidy that up, and the constant equals 0, because as it passed over the finish line, how far is it from the finish line? Obviously 0. So we then put 4.5 into our equation for the time to find the distance. So substituting 4.5 for t, we find the distance is 101.25 meters. That will give you relational thinking. Now for the next one, Sharon has a sheet of cardboard, 16 by 10, so draw a diagram. Cut your 4 corners of x out of the sides there, and label your sides. 16 centimeters long, so the length in blue for the base would be 16 minus 2x, and for the width it would be 10 minus 2x, and the height would be x. Volume is length times base times height, or base times length times width, whatever. Multiply those 3 sides together. Now by using FOIL, expand out your first one, because we want the maximum volume before you differentiate it. Tidy up your brackets. So first, outside, inside, last. 16 times 10, 16 times -2 gives you 32. -2 times 10 gives you -20. And -2x times -2x is 4x squared. Tidy that up. The two middle terms make -52. Multiply each term by x. Put the 4x cubed at the front just to tidy it up a bit, and the 160x at the end. Now we want the maximum volume, so we are going to differentiate it. Multiply by the power, reduce the power by 1, tidy it up. Because we want the maximum, we've got to find out when it equals 0. You could use factorising, the quadratic formula, or your calculator to find the 2 points where it equals 0, and it's 20 over 3, or 6 2/3, or 2. One of those is a maximum, one is a minimum. When you put 2 into the equation, it gives you a maximum volume of, let's wait for it, 144 centimetres cubed. If you put 20 over 3 in there, you'll find it's not the maximum volume. That's excellence. That's easy, wasn't it? Okay, the next one. Here, and this is perhaps the easiest question of them all, if you do it piece by piece. Just bear with us on this one. During the first month, the price was increasing at an increasing rate. So it's going up. It starts increasing slowly, then increases faster. So you could have a curve like that. The second month, the rate of increase was slowing. So it started off fast and it slowed down. It was still increasing though. So this brown one that I've just drawn is the second month. Then the third month, it began to fall at an increasing rate. So it started falling slowly and then increased more rapidly. And last, the price of the petrol was constant, but it was higher than the initial price. So, started off, here's your first month, tag on your second month, tag on your third month, and do your fourth month. And they're going to give you excellence for that. It's ridiculous. Okay, there's question 1.